Next, let's talk about sampling. Quantization is a technique for expressing amplitude with a limited number of numbers. This time, let's think about the time axis. Like amplitude, time is expressed as a continuous or infinite value. This also cannot be entered into the computer. So we need to decide how many values to take and use per unit of time, for example, 1 second. This is called sampling. If you use too few samples, distortion will occur, as before. And if you use too many, there will be too much data to process. How can I take the appropriate number of samples? This is where a somewhat difficult concept comes into play, Nyquist sampling theorem. This is a theory proven by a person named Nyquist. To put it simply, omitting the details, it says the original signal can be perfectly restored if you sample at a frequency twice the maximum frequency of the signal you want to restore. Human hearing frequencies range from approximately 20 Hz to 20,000 Hz. There are various sounds in the world, but there is a limit to the range of sounds that humans can hear. Since we can't hear it anyway, sounds outside this area are outside of our interests. Among the words in the Nyquist sampling definition mentioned earlier, there is the word maximum frequency. I told you that the maximum frequency that humans can hear is approximately 20,000 Hz. Then, according to the above theorem, this means that sampling at 40,000 Hz means that all sounds audible to humans can be perfectly restored to human hearing. What would happen if sampling was done at a sampling rate lower than the maximum frequency? This signal you are seeing is 20 Hz sine wave. Let's sample and recover this signal at various sampling frequencies. This is when the sampling frequency is 15 Hz. Although points of the original signal were taken from time to time, the original signal could not be properly recovered. When recovering a signal in this way, the phenomenon of incorrectly recovering a signal of a different frequency due to an incorrect sampling frequency is called aliasing. This time it is 20 Hz. If you sample with the same period as the maximum frequency, you can see that the signal is restored to a half period. This time it's 30 Hz. It's still not enough. It is 40 Hz, which is twice the frequency of the original signal. Its sampling rate is twice the original signal's frequency. Only now can we recover the 20 Hz signal by identifying the points that can perfectly restore the original signal. In conclusion, if you do not sample more than twice the original signal, you will not be able to recover the original signal because you will not be able to capture enough points that make up the original signal. This also leads to sound distortion, which is called aliasing. Earlier, we told you that the human hearing frequency is 20,000 Hz. Therefore, in theory, there should be no difference in hearing the sound source sampled at 40,000 Hz from the original sound source. Of course, there may be individual differences. That's why the sampling rate of CDs is 44,100 Hz. The reason it's not exactly 40,000 is because the company Sony made it that way when they made the standard. The table below lists frequently used sample rates and their purposes. As with quantization, there are problems with memory and processing speed and always using high sampling frequencies, so various sample frequencies are used in various application environments. Let's listen to how the sound becomes distorted when sampling below 40,000 Hz. As the sample rate decreases, you can hear the sound becoming more and more different from the original sound, that is, distortion becoming more severe. However, if this distortion has a minor effect on the intended application, it can be said that it is efficient to use a sample rate of as low a frequency as possible. Let me briefly summarize what has been explained so far. First, we talked about the waveform and its rough outline or envelope. Next, we talked about quantization, which refers to how to express the amplitude by dividing it into a limited number of numbers. Lastly, we talked about sampling, which refers to how many samples are taken during a specific time. According to the Nyquist sampling theorem, if you sample with a sample frequency that is more than twice the signal you want to recover, we can guarantee that the signal can be fully restored. The topics we will talk about next are as follows. Let's talk about what a spectrum is, what a spectrogram is, what a Mel spectrogram is, and finally, what a filter is. Thank you.